Okay. So this is our agenda today, right? So we'll try to understand DevOps definition and how this process is useful, and then how to design this process. Okay, how can we design the DevOps process design? Okay, so how to design this process? Why we need to understand this DevOps designing process is because see, our as a DevOps engineer, our main responsibility would be to design DevOps process. That's the main responsibility. Okay, and we have few more responsibilities as well. Okay, but this is our one of the most main responsibilities in our real time. Okay, as a DevOps engineer, okay, and we have some other responsibilities as well. Okay, we'll look into DevOps engineer responsibilities in tomorrow's session. But in today's session, we'll try to understand this. Okay, and then after that, we'll look into configuration management part. Configuration management. What is configuration and the definition? So we'll look into all these things clearly in today's session, right? So this is our today's agenda. Clear? Right. So let's start with first. What is DevOps? DevOps definition. Okay, clear? So first we'll look into project flow. The project flow. Okay. Now, once the project has been designed, okay, sorry, not project design. Once the project requirements has been gathered. So what do you mean by requirements? Like software requirements, hardware requirements, right? Application requirements. Once all those requirements are gathered, then all those requirements will be forwarded to the stream development team. Okay, and then development team will start designing the application based upon the requirements. Clear? Right. So we'll start from development phase, because as a DevOps engineer, always we start with development, team and end with production. And whatever the phases like requirement phases and agile methodologies, we have few more things as well before the development phase. But we don't need those things, agile or whatever it is. But we need to understand from this phase, development phase onwards. So what are the pre-phases of this development? Okay, we should not bother about those phases, right? So what phase here? This is the dev phase. This is the dev phase. Okay, development phase. Then, so after the development phase, what would be the next phase? Obviously, we all know this, the test phase. So once the project has been designed in development phase, what happens? What would be the next phase? The test phase, right? Test phase. Okay, and then after that, the deployment phase. Okay, deployment phase. So I want to deploy onto production systems. Just the deployment phase. So we have these three main important phases in our project. Okay, so we have few more things, but these are major parts. Okay, right. Sorry. So development phase, test phase, and then production phase, deployment phase. Okay. Right. Now, let's talk about development phase now. Okay. So what a developer does. What is the main responsibility of a developer? Application design, developing, right? Programming the application. Okay, we know this. Just say I have a Java developer. He is designing some application. He is designing an application. Clear? So the Java developer is designing this application. Now, so once the application has designed, what developer apart from application designing by the developer has to do few more activities. Okay, so what are those activities? Developer has to compile application. See, application designing is not at all enough. Okay, of course it is important phase. Without the application we can't proceed. So once the application is designed, application has to be built. What do you mean by built? The compilation phase. Okay, so once application is designed, application has to be compiled. But why do we need to compile it? To test the syntax issues. Okay, as well as one more important thing is we need to generate the binaries of the application. Understand? We need to generate the binaries of the application. Okay? Okay? But why do we need to generate the binaries? Yeah, because systems understands only binary formats. See, system doesn't understand what is Java. The system understands Java, but if the system is already installed Java application, then system understands Java source files. Otherwise, system doesn't understand what is Java. So it's not mandatory that every system should have the JDK installed, Java Development Kit installed. But what if we don't have JDK installed? Still, I want to run my application. Then that is the reason we have every application will have the binaries. Clear? So that means whenever the project has been designed, once the project has been designed, the project has to be built first. Okay? So build operation. Build, or else you can call it compile. Build or compile. Okay, and then once it is built, that has to be packaged. That has to be packaged. Okay. What is package? See, it's not mandatory that every project will have one class file. See, usually project will be having hundreds and lots of class files. But what is the class file here? What is the class file? Class file is in Java. Okay. So what is a class file? And before I enter into what is a class file, look at here. I just want to remind you everything that, see, if you as a DevOps engineer, we should not know what is Java. I mean, we should know what is Java, but we should not know. Okay, it is not mandatory that you should know about Java terminologies. Okay, Java programming. Okay, these are not requirements. Okay, see, we are not going to work on Java. First of all, let me make it more clear. Okay, because I get this question whenever we start with something. Whenever I say Java and so and so. But so as a DevOps engineer, we are not going to deal with any Java. We are not programmers here. Okay, but the programmers, we need to build the application. Okay, I'll talk about this later. But remember this: as a DevOps engineer, you should not know anything about Java. Only we need to know few things, few basic things. Okay. Anyway, I will cover that part as a part of the course. Okay, clear? Right. Now, what is the class file in Java? Binaries. Okay, so class files in Java means the binaries. Okay, right. Now, but if the application has got, just say application has got some 500 dot class files, 500 dot class files. Okay, then what do? I want to deploy that application. So are we going to deploy dot class files? No, we are not going to deploy dot class files. We are going to deploy only the packages. What do you mean by package? Package means collection of classes. Okay, for example, I have 500 dot class files. So I'm going to package into, I'm going to package that into one file, which is package. I call it package. Right. So packaging means bundling or collecting all the classes into one file. That is what do you mean by package. Okay. So compiling, that means building the application, as well as packaging the application is part of, who is responsible for that? Developer is responsible for that. Okay. So now let's talk about the test phase. Okay, remember these steps. I'll come back to these steps again later on. Okay, now let's talk about test phase. Okay. So I want to, for example, I have an application. Okay, I have an application. I want to test that application. So if you want to test an application, first of all, you need to have the test scripts available for the application. So with the help of the test scripts, we are going to test the application, right? So that means first write the test scripts. Who does this part? The testers or test engineers. Okay, writing the test scripts is test engineers part, tester part. Okay. Now, apart from that, he has to test the application, right? See, writing is one part, and the second part would be testing the application. That means running these test scripts. Okay, I want to run the test scripts now. Okay, run the test scripts. Run the test scripts. Okay, right. But how do they run the test scripts? With some manual efforts. Okay, that's a manual activity done by the test engineers. Running test scripts is a manual activity done by the test engineer. Okay, and then what is the next phase? The deployment phase. Okay, next is deployment phase. The deployment phase. Okay, so in this deployment phase, the application will be deployed onto whatever the server. Like here, I'm talking about production servers. Okay, but if the server is UAT server or pre-production servers, okay, right, then you can deploy that application onto so and so whatever. But here we are talking about the production servers. Application has to be deployed to the production servers, right? Right. Okay. Just say application. Okay, everything is gone good, and application has been deployed successfully. Okay. Now, so that's okay. Okay, its application is going smooth. Okay, no issues. But now, for example, just say, let's talk about these manual steps. Okay, so even deployment. Okay, let me put it here. The deployment. And one more thing here. Who does this deployment activity? Who does this part? Administrators can do, or else release engineers can do. Administrators or release teams. Okay, release teams. That is, okay, these teams are responsible for the deployments. Okay, right. Now, so the administrators or release engineers. But how do they deploy it? Again, with manual activities, with some manual steps. Okay, with some manual steps. Okay, they follow some manual activities to deploy the application. Understand? So what do you mean by deploying? To be simple, copy and paste the application. Copy the application which is already tested and paste it onto the production servers. Okay, that is what we call deployment. Okay, so but here we are talking about, okay, building, packaging, running the test scripts, and then deployments. We are talking about these things. Okay, but as I said, these are manual activities. These are manual activities done by these teams: development team, testing team, or else some release teams, admin teams. Okay, so if you go with manual steps, what is the disadvantage? It's time consuming, right? And we can do errors. And then moreover, if you talk about from company perspective, that is cost. Understand? If you want to avoid these disadvantages, that means cost as well as time, okay, and then perfection, right? Then what's the solution is automation. Understand? Automation is a solution. Automation. Okay, that is DevOps. Okay, so DevOps. So DevOps is an automation process. Okay, DevOps is an automation process. Okay, with the help of the process, you can perform all these activities. Understand? You can package it. Okay, you can build it. You can test your application as well as you can deploy your application. Okay, so whenever we introduce this process into our projects, okay, just say I have an application. Okay, I have a project. Okay, say I have a project here. I have a project. Okay, so I want to introduce DevOps process into this project. Okay, I want to introduce DevOps process, automation process. Understand? So once we introduce this DevOps automation process into our project, then there won't be any people working on these manual activities. What are those manual activities? Building, packaging, running, and deployment. Okay, that means we don't need any resources to do these manual activities. Understand? Okay, so as a DevOps engineer, so we need to design this process first. See, here we are talking about the process, but is this process predefined? No, it is not a predefined process. Okay, and this process is not already available. We need to design the process based upon our project requirements. So every project will be having different requirements. Understand? Every project will be having different requirements. So we need to design this process as per our project requirements. Clear? So we need to do that. So as a DevOps engineer, our main responsibility is to design the DevOps process. That means automation process. To design the automation process. Okay? And then see, is it mandatory that every automation has to be success? It's not mandatory. Right? So it's not mandatory that every process, every DevOps forget about DevOps. Okay, we have some other automation processes as well, like RPA. Okay. So if you take that process as well, is it mandatory that process has to run smoothly and successfully? No, it's not mandatory. The process may get failed, right? So if the process gets failed, then you need to monitor the process. Okay, monitor the process. Okay, so the responsibilities are mainly design the process as well as monitor the process. See, do we design this process every time? No. See, for one project we have one process. So design the process and configure the process into the project. So once you configure the process into project, then process will be working as we wish. That means we don't. Okay. That means we don't need any persons, any people, any resources to work on this, to look after this process. Okay, but since the process may get failed, there are chances that process may get failed. So in those cases, we need to debug the process. That means we need to monitor the process. We need to keep on an eye on the process whether it's going smoothly or not. But designing the application is one-time activity. So it's an automation process, right? So it's a one-time activity. Okay, but the monitoring is, it's a daily routine. Monitoring is daily routine. But how do you monitor that process? So here, monitoring, I'm talking in terms of DevOps. I'm talking in terms of DevOps. Okay, because we have one more term called monitoring. Okay, the monitoring servers. Okay, that's a different terminology. But here I'm talking about monitoring the DevOps automation process. Okay, that's a different. See, don't get confused between monitoring the servers and monitoring the DevOps automation process. These two are different things. Okay, but as of now, we are looking into DevOps or automation process monitoring. Okay, clear? Right. So these are your responsibilities. Design the applications or design the process as well as monitor the process. Okay, is this clear? Now, that means whenever we introduce this automation process into our organization, okay, then from that point onwards, we don't need any people to work on these activities. That means building, testing, and deployment. Is this clear? That is the purpose of automation process, DevOps automation process. Okay, automatically process has to build the application, package it, and then run the test scripts. That means test the application and then deploy the application. Okay, so to be simple, if you want to define the DevOps automation process, okay, It's a continuous integration and then continuous deployment process, deployment automation process, automation. So what do you mean by continuous integration? Continuous integration. What is that continuous integration? See, every application, okay, will take some time. That means probably it may take some months, right, to design the application, right? Okay. So first, the project team will set some timelines, time bounds. Okay, within the time bound, the developer team has to finish the designing the application within the time limit or time bound. Okay. Now, so within the time bound, what we need to do is, or what the developers will do is, developers will keep on changing the application source code. Okay, developers will keep on changing the application source code, right? That means they do changes to the application source code every day. So that means whenever application source code has been changed, obviously it has to be compiled. So it is like continuous process, right? So daily developers will keep on changing the source code and source code has to be compiled. It's a continuous process, right? So that's why we call it continuous integration. But what is integration? Okay, we'll talk about what is continuous integration and continuous deployment in that would be our next topic. Okay, that means how to design this process. Okay, but continuous integration as of now, why we call it continuous means because developers keep on changing the source code and then we need to keep on building. But do we build it manually? No. The process is going to look after the build operation. Understand? So is this clear? Right. So if it is clear, let's move on to the next topic, okay, which is how to design this automation process. Okay. Design DevOps process. Okay. Design the DevOps process. Okay. Now we'll look into this, how to design this process. Okay. Right. There is a tool called Jenkins. Okay, the tool name is Jenkins. Okay, Jenkins. Okay, so what is the purpose of this tool is Jenkins provides a platform to design the DevOps process. Okay, Jenkins provides a platform to design DevOps process. Okay, it provides a platform. Okay, and is a tool as well. Okay, is a tool provides a platform to design the DevOps process. Okay, now, so based upon Jenkins, that means with the help of Jenkins, we design the DevOps automation process. Okay, clear? Now, let's look into that now. How do we design it? So with the help of Jenkins, so I want to design the DevOps automation process. Okay, just say this is the process, DevOps automation. Okay, now, but what this process has to do? Sorry, yeah, I think I got some answer here. What the process has to do? It has to build the application, right? It has to build the application and then package it, okay, and then as well as test it and then deploy it. Okay, so process has to perform these activities, right? Now, but so first we'll look into this building and packaging. So I want to build my application. Okay, So what do you package actually? What do we build actually? We build the application, but what the application contains? The source code, right? So application contains the source code. That means, see, here we are talking about the DevOps process, right? Okay, so application has to, sorry, the process has to build the application. If the process wants to build the application, it has to know what is the application source code is. Where is the application source code is? Understand? So it has to first, the process has to fetch the application source code first. Understand? Right. Now here we are talking about application source code. Okay. So process has to fetch the application source code first. Okay. But from where? From which location? Okay. What do we call that location in terms of DevOps? Okay. Now, but before that, one thing here, I have a, okay, 50 developers are designing application. They're designing a Java application. Okay, so that application, okay, that means we have 50 developers, and where do the developers will save the source code? Do they save it on their local system? Yeah. So the developers will save the source code on a central repository. So what is a repository here? So repository is a kind of a shared drive. Okay, they save the project source code onto a shared drive, which is we call it in terms of, okay, technically we call it repository, central repository. Why we call it central? Because it is located somewhat commonly. That means on some common server. Okay, so we call it central repository. We call it central repository. Okay, right. So repository purpose is to maintain the project source code. Okay. Apart from that, what is the purpose of repositories? Version controlling. Version controlling. So what is version controlling? We'll talk about that after a few minutes. Okay. Now, here. So we are talking about this repository. Okay. Now, but if you want to create a repository, obviously we need to have some tools, right? So the tools what we have is mostly used tools, mostly available tools is SVN, Git, and then GitHub. SVN, Git, and GitHub. Okay. Then, so with the help of these three tools, we can design repository. Okay. So I'm going to cover these three tools. That is part of the course. Okay. I'm going to cover these three tools. Okay. And mostly used tool as of now is GitHub. Okay. In organizations, most of the organizations they're using GitHub. Okay. Right. Now, so I'm going to cover these three tools anyway. With the help of these tools, yeah, I have a question here from Sunil. Yeah. So of course TF is also used. Okay. So the question is from Sunil that, so TFS. Okay. So TFS is also a repository tool. Okay. So, but that is as of now, here organizations they prefer the cloud repository. See, GitHub is a cloud repository. Okay, TFS and then SVN, Git are local repositories. Okay, so these are all local repositories, but GitHub is mainly used, which is on cloud repository. Okay, then TFS is also same as a repository like SVN, which is local repository. Okay, fine. Now here, where was I? GitHub, right? Okay, I was talking about the GitHub. Now, so as a DevOps engineer, our main responsibility is to create these repositories. Okay, and then see, different projects may have different repositories, right? So to create the repositories is our responsibility as a DevOps engineer, and as well as to give access for the developers of the particular project. For example, we have three projects, just say project A, B, and C. And project A team should not have access to the project B repository, right? And project B team should not have access to A and C, right? We need to restrict that. So that is what we call access control. So access control is our responsibility as a DevOps engineer, and as well as version controlling, VCS, version control system. What do you mean by version control? So whenever some bulk of users, some bunch of users working on a project, so there are very good chances that developers may delete some wrong files, or developers may do edit to the wrong files, right? So they may access the wrong files, and they may edit the wrong files, or they may delete those files by mistake. So if they do such kind of things, we need to, as a DevOps engineer, we need to restore those tools back. Sorry, we need to restore those files back. Understand? That is what we call version controlling. Okay. So as a DevOps engineer, that is our job. Okay, create the repositories, access control, and then version controlling, and as well as taking the backup of those repositories. Okay, clear? So that is our responsibility. Now, okay, so let's come back to the process again. So where was I? I was at build step, build and package step, right? Now, but see, when we say automation process, the process has to do everything. It has to fetch the source code, as well as it has to do all these build, package, test and deploy activities. Clear? No. So now the process has successfully fetched the source code from the repository. Okay, so the first step is finished, and then let's enter into the automation process now. Okay, so this is the build and package. But look at here. So Jenkins, as I said, Jenkins is a platform. Okay, Jenkins is a platform, and with the help of that Jenkins tool, we design the automation process, the DevOps automation process. But Jenkins does not understand what is building, what is packaging, what is testing, what is deployment. Jenkins doesn't know these activities. Okay. See, as I'm saying that Jenkins, with the help of Jenkins, we design the automation process. Yeah, but I'm also saying that Jenkins doesn't understand these steps. That means I'm contradicting here. But Jenkins does support all these steps. But how? So we need to integrate some tools. Okay, we need to integrate some tools. With the help of those tools, we can perform these activities. That means we are using some third-party tools. We are integrating some third-party tools into Jenkins. Then Jenkins, with the help of those tools within Jenkins, we can perform these activities. Am I clear? Okay. For example, let's say, okay, I want to do build, I want to package. I want to perform these activities, build and package. Okay, I want to build and package. Then, so if you want to build and package, first we need to select the tools. With the help of those tools, you can perform these activities within Jenkins. Okay, so for example, we have and then Maven. We have these tools. Okay, with the help of these tools, you can perform these activities. So select the tool as per your requirement first. Okay, select the tool as per your requirement first. So I want to select here Maven. I want to select Maven tool first. Okay, select that tool and integrate that tool into Jenkins. Okay, integrate that tool into Jenkins first. Integrate into Jenkins. Then you can use the tool within Jenkins. Understand? See, Jenkins doesn't know what is particular build activity or whatever. So, but if you want to do that, integrate that particular tool into Jenkins first. But how do we do? With the help of plugins. So with the help of plugins. Okay. So with the help of plugins, you can perform these activities. Understand? Okay. So in Jenkins, we have a concept called plugins concept. So with the help of plugins, you can do that. Understand? So every tool in Jenkins is a plugin. Every tool in Jenkins is a plugin. Okay. But select based upon your requirements, select the tool. Sorry. So based upon a requirement, select the tool and integrate it into Jenkins. That is, download the plugin into Jenkins. Okay. And then you can use either AND or Maven as you wish, as per our requirement. Okay. Then what's next? We have test. I want to use Selenium as a test tool. Okay, I want to use Selenium. I want to test my application with the help of Selenium. How do we do? Okay, so as I said, download the particular plugin into Jenkins. Then you can use that Selenium tool into Jenkins. Okay, clear? So that's how you can do. So based upon and moreover, and the next thing we have is deployment. Okay, deployment here. Okay. Now I want to deploy it. Again, we need to download the deployment plugin and install it in Jenkins. Then you can use that particular tool. So I just want to name one plugin here. With that plugin, you can do deployment. The plugin name is deployment container, I guess. Yeah, deployment container. Deploy container, not deployment. Okay, so deploy container. So with the help of deploy container plugin, you can do deployments as well. Okay, for example, I want to deploy that onto Tomcat server. You can deploy that. If you want to deploy that to JBoss, okay, Glassfish, WebSphere, WebLogic servers, okay, you can deploy that onto whatever the service it is. Understand? But first of all, you need to download and install that plugin within Jenkins. Then you can deploy it. With the help of that particular plugin, deploy it. You can go for deployments. So to be simple, Jenkins works on plugins basis. Okay. And moreover, the advantage with Jenkins is it's a graphical user interface. It's a UI tool. It's a graphical user interface tool. So I think we know the advantages of UI tools. It's easy to work on. You can easily work on. So go to the options, select it, and save it. So that is the advantage of Jenkins. Okay, and moreover, Jenkins supports most of the tools. If you want to use any other tools apart from these tools, like Puppet, Chef, Ansible, Docker, okay, it supports all those tools. But what is Puppet, Chef, Ansible? Okay, we'll look into this concept, the configuration management concepts, in tomorrow's session. Okay, so configuration management part. Okay. So configuration management part. Okay, we'll look into this session tomorrow. Okay, that is very, very important for DevOps engineers. But as of now, okay, this is all about our DevOps, how the DevOps process works. Okay, so to simplify, okay, DevOps, okay, as I said before, continuous integration, okay, continuous. Okay, DevOps is a automation process. Automation process. So with a used to continuous integration and then continuous deployment activities. But it's an automation process. Okay. Now you understand what is continuous deployment. That means look at here. So the process has to fetch the source code continuously. The process has to fetch the source code continuously from the repository, and then it has to do these activities: build, test, and deploy. And this is a continuous process. So whenever something has been changed on the repository, that has to be fetched and then compiled, build, whatever. So that's why we call it continuous integration and continuous deployment. So we need to integrate our repository, our project repository with DevOps automation process, and it will fetch the source code continuously from the repository, and it will keep on building it and deploy it. Okay, clear? So that is all about today's session. And if you have any queries, okay, so if you have any queries, anyone, okay, you can, one second, sorry for that, you can contact Alltech IT. Okay, here, one second, sorry guys. Yeah, so you can contact, okay, let me make it, so Alltech IT, okay, and the contact number is, if you are located, okay, it's +91 96 42 109 756. It's 9246 109 756, and the email ID is Alltech IT training, okay, @gmail.com. Okay, it's Alltech IT, and the contact number is, it's a contact number, you can call it, or else if you want to contact through email, it's Alltech IT training @gmail.com. You can contact. Okay, thank you very much. Signing off. Thank you.